Welcome to the deep dive. Today, we're really digging into operational excellence, specifically a concept that sounds technical but is incredibly powerful, Heijunka, or production leveling. We're using insights from OpExNZL, and our goal really is to figure out how these ideas can transform efficiency, responsiveness, and cut waste.
Right.
And not just in factories,
Yeah.
We think this applies whether you're managing a team, a project, or even just your own daily tasks. Might be some aha moments here.
Absolutely. And that's the key takeaway we want you to get. These principles, they offer really practical ways to deal with those common feast or famine cycles in workload.
Yeah, the swings.
Exactly. So you can meet different demands more precisely and ultimately just create a smoother, more reliable way of operating. It's about finding consistency.
Okay, so let's unpack this before we jump into Heijunka itself.
Yeah.
Our sources make it really clear. There's some groundwork you absolutely have to do first.
Yeah, you can't skip these.
Think of them like the basic habits, right? The things that make the advanced stuff even possible.
Right. That's a great way to put it. They're non-negotiable, really. They create the stability you need. Without them, trying something like Heijunka, well, it's likely to just fall apart because the base isn't solid.
Okay, first up, 5S. This is all about creating a super organized workplace. The mantra is simple: a place for everything and everything in its place.
Sounds basic, but it's profound. Think about it even for, say, a remote team working on software. 5S isn't just a clean desk.
Right.
It's about having standardized digital folders, file naming, clear documentation. When you have that normal, anything out of place, any abnormality, it sticks out immediately. Saves huge amounts of time searching.
Makes sense. Then there's standard work. This means clearly defining the normal way to do any task or run any area.
Yeah, setting the best practice, how to do the work, cleaning schedules, maintenance, whatever it is, usually with visual guides so it's easy to see and follow.
So it takes the guesswork out.
Exactly. No ambiguity. Think customer service standard work means there's a clear process for handling calls, escalating problems, even bringing new people up to speed quickly, predictable quality.
And that leads to quick changeovers, or SMED. This one's critical. It's about drastically cutting the time it takes to switch from doing one thing to doing another. Our source details like 4 key steps for this. Things like improving scheduling, figuring out what setup tasks you can do while the machine or process is still running.
Yes, separating internal from external setup.
Right. And converting as much as possible to that external while running setup, then streamlining everything else.
And what's really interesting is the benchmark they throw out there. They ask, have you reduced your setup times under 10, 15 minutes?
Whoa, that's ambitious.
It is. It forces you to scrutinize every single second. Think about maybe a consultant switching between client projects. How much time is lost just pulling up the right files, remembering the details, setting up software. SMED thinking pushes you to slash that friction.
It really hits home how these ideas aren't just for factories. Organizing your digital life using 5S principles. Standardizing how your team runs its weekly sync using standard work. Or cutting the setup time for your next marketing campaign using SMAD. It's all about operational agility wherever you are.
Exactly. It's universal.
Okay, so we've got stability covered with those foundations. But stability isn't the whole picture, is it? We need agility too. We need to respond to what's actually needed without creating waste.
Right, and that's where just-in-time, or JIT, comes in. It's really the core philosophy that paves the way for something like Heijunka to work effectively.
And JIT, at its heart, is pretty simple conceptually, making what the customer needs when they need it in the quantity needed.
Deceptively simple. But the power is immense. JIT forces you to use the absolute minimum resources, effort, materials, equipment, space.
And crucial.
And crucially, as our source points out, it exposes hidden problems and the 7 wastes of operations. Because there's no buffer, no fat in the system, inefficiencies just can't hide anymore.
Okay. And JIT itself is built on 3 core pillars, right? Our sources lay these out as takt time, flow production, and pull systems.
That's it. They all work together.
Let's start with takt time. This sounds like the rhythm section.
Haha, yeah, it's exactly that, the heartbeat. It's defined as the time available to produce a single item based on customer demand.
So it sets the beat.
It literally sets the pace for work, aligning how fast you make things with how fast customers buy things.
What are the big wins with takt time?
Well, it directly tackles overproduction you only make at the rate needed. It helps allocate people and machines super efficiently, reduces inventory, obviously, and boosts your on-time delivery because you're paced to actual demand.
Where does it work best?
It's ideal when you have fairly standard products, standard processes, and you can forecast customer demand with reasonable accuracy.
Okay, let's make this concrete. The source gives us Smith's Small Manufacturing Company. They make 3 models, A, B, and C. Different weekly volumes for each, but they all take 34 seconds of work to produce.
Right. So to find their takt time, you take their total available work time per day, which is calculated by taking the shift length minus breaks minus lunch.
Okay.
And you divide that by the total number of units customers demand per day across all models. The source walks through the math.
Yeah, result.
The result for Smiths is a takt time of 18 seconds per unit.
18 seconds. So what does that actually tell Smiths?
Well, think about it. If any product takes 34 seconds of actual work time,
Yeah.
but the customer needs one finish every 18 seconds to keep up with demand,
Yeah.
you just divide 34 by 18.
Which is almost 2.
Exactly, about 1.9. So you need 2 workers assigned to that product or process step to meet the takt time. Any more, you'll overproduce. Any less, you fall behind. It's that precise.
Wow. Precision allocation.
It really is. But success depends heavily on getting that customer demand data right and recognizing you might have internal customers too, like admin processes needing a takt time. And of course, being ready to adjust when demand changes.
Okay, that's takt time, the beat. What's next? Continuous flow.
Right. Continuous flow is about making things move smoothly, one piece at a time, from one step directly to the next without stopping or batching up.
Like a relay race, almost.
Kind of, yeah. The goal is to link processes together, especially those with similar timings, so work just flows seamlessly. One part or order goes through, gets passed on immediately.
What can I do for you?
Huge benefits. It drastically cuts down work in process, that stuff sitting between steps. It makes problems visible instantly because there's nowhere for defects or bottlenecks to hide and accumulate. Lead times plummet, and it uses people really efficiently, especially if they're cross-trained. The source has a great comparison. Batch production might take, say, 30 minutes for an order, with the first item out in 21 minutes. With continuous flow, same work times per step, that could drop to maybe 12 minutes total, and the first piece is out in just 3 minutes.
Yeah.
It's a massive speed up.
So how do you make continuous flow happen?
A key enabler is cellular manufacturing. This means organizing your workspace into little production cells, often U-shaped.
Well, you
It minimizes movement. Equipment is laid out in sequence, so one operator can often manage multiple steps within the cell, just turning or taking a short step.
Got it.
And again, this isn't just for factories. Imagine a campaign cell in marketing. You put the copywriter, designer, digital person together, physically or virtually.
Okay.
And the work for that specific campaign just flows directly between them within that dedicated cell. Much faster, more flexible.
So success factors, there are things like arranging the cell logically, using visuals to spot problems, and making sure people can do multiple jobs cross-training.
Exactly. Fluidity is key.
All right, so we have takt time, setting the pace, continuous flow, smoothing the movement.
Yeah.
What about controlling when things move? That sounds like pull systems.
Precisely. What is a pull system? It's fundamentally different from push. In pull, resources only flow when they are needed downstream. You only replace what has been consumed.
So nothing gets made or moved until the next step signals it's ready.
You got it. It's the opposite of a push system where you just make stuff based on a forecast and hope someone needs it eventually, which often leads to piles of inventory.
Right, the classic overproduction waste.
Exactly. Pull eliminates that. It controls inventory naturally. It synchronizes everything. It highlights bottlenecks because if a step can't pull, things stop.
Makes sense.
And it makes the whole system driven by actual customer demand, not forecasts.
Where do you see pull systems?
Honestly, everywhere. Once you look, the classic example is the supermarket shelf. They only restock it when you, the customer, pull an item off.
Okay.
But it's on the factory floor between processes. It's used for office supplies, managing information requests, anywhere replenishment should be triggered by actual use.
And the tool that makes pull work is Kanban, right?
Yes, Kanban is the signal. It's the mechanism for the whole. It's often a physical card, but can be digital too. It basically says, hey, I need this specific thing in this quantity right now.
It's the trigger.
It's the trigger. It's the permission slip for the upstream process to produce or send more. Without the Kanban signal, they don't act.
And they're different kinds.
Yeah, the source mentions a few, like withdrawal Kanban to get parts from a storage area, production Kanban to tell a process to make more, and signal Kanban maybe for hitting a reorder point. But the principle is the same. A visual signal authorizing action.
Give us a simple example.
Okay, imagine Team A makes reports for Team B. Without Kanban, Team A might just keep churning out reports based on a guess.
Right. Pile them high.
Pile them high. With Kanban, Team A only starts a new report when Team B sends back a Kanban, maybe an email, a ticket, whatever, saying, we finished processing the last report, send the next one. Team B pulls the work.
So the Kanban itself usually has key info. Part number, quantity.
All the essentials.
Yeah.
Part number, where it came from, how many per card or signal, where it's going, maybe a reorder point, clear and simple.
Got it. And there are rules for Kanban.
Absolutely critical rules, like never produce more than the Kanban authorizes. Only act with a Kanban signal. Never pass defective stuff downstream. The Kanban signal has to stay with the parts or task. And you need to review the number of Kanbans regularly to match current demand.
Okay. Takt time, continuous flow, pull systems with Kanban.
Like,
We're building towards something big here.
we are. We're building towards the strategy that ties it all together for ultimate flexibility and efficiency, especially when you have variety. And that is Heijunka, production leveling.
Heijunka, production leveling. Define that for us.
It's a scheduling method, but instead of making big batches of one thing, then a big batch of another, Heijunka aims to intertwine the production of different products or variations, mix them up throughout the day, the hour, even down to the minute.
So instead of making all your Model A's on Monday, Model B's on Tuesday.
Exactly. You make a little bit of A, then a little bit of B, then maybe some C, then back to A, and so on, in a repeating pattern all day long. You level out the mix and the volume.
Why? What's the big advantage of doing that? It sounds complicated.
It unlocks incredible flexibility. It lets you smooth out those bumps in customer demand much more easily. It drastically cuts inventory, both raw materials and finished goods. It perfectly supports the pull system concept.
Okay.
And crucially, it gets rid of that awful feast or famine workload, where one day the team is swamped making product A, and the next day they're idle waiting for product B orders. Leveling avoids that.
This feels like the real aha moment.
Yay.
Let's use that source example. Say demand over 3 days is 120 of A, 150 of B, 210 of C.
Right. Batch production would mean day one. Make all 120 A's. The B and C lines might be idle or underutilized. Day two. Make all 150 B's, A and C lines idle. Day three. Make all 210 C's maybe needing overtime because it's the biggest batch. It's inefficient and stressful.
Okay, I see the problem. So Heijunka.
With Heijunka production leveling, you'd figure out the daily average. So 120A over 3 days is 40A per day. 150B is 50B per day. 210C is 70C per day.
Oh.
So every day, you produce 40A, 50B, and 70C. You mix them up in a repeating sequence throughout the day. Now your people and equipment are consistently utilized every day. Much smoother, less waste, and way more flexible if demand suddenly shifts midweek.
That makes a ton of sense.
Yeah.
Where does leveling work best?
It's most powerful where you have that variation, different customer demands, lots of product models. And critically, you need those standard process times we talked about earlier so you can calculate your takt time. And also something called pitch.
Pitch? What's that?
Pitch is basically your takt time scaled up to a convenient container size. If moving single pieces isn't practical, pitch is the regular time interval at which you move a standard box or batch of items. It becomes the rhythm for material handling.
Okay, so how do you actually do Heijunka? What are the steps?
Well, first, you need your takt time, available time divided by total demand volume. We covered that. Second, you calculate pitch. That's takt time times your standard pack-out quantity per container, usually converted to minutes. You figure this out for each product type and usually base your schedule on the smallest, fastest pitch.
Okay, smallest pitch sets the interval.
Yep. Third, you define the production sequence. Based on that smallest pitch, you map out repeating blocks of time across the day. Fourth, you create a sequence table. This is your visual plan, maybe laminated on a whiteboard. It shows exactly which product, how many, and in which time slot they run. Like 7.00, 7.15 product A, 7.15, 7.30 product B, etc.
And finally,
you often implement a leveling box or Heijunka box. This is the physical tool to manage the schedule in real time.
what does that look like?
Imagine a wall rack with lots of little pigeonholes or slots. Each row might represent a product family or pitch interval. Each column represents a time slot during the day. You put the Kanban cards for the work into these slots according to your sequence table.
Ah, so it's a physical representation of the schedule.
Exactly. And usually you have runners or material handlers who take the Kanban card from the next slot at the designated pitch time, get the materials, and deliver them to the workstation, bringing back the completed work's Kanban. It makes the schedule tangible and visual.
What happens if they can't complete the work in that pitch time?
That's key. There needs to be a system for immediate support. Supervisors get alerted, help is provided. The goal is to solve problems instantly, not let them disrupt the leveled flow.
The results seem pretty dramatic. The source mentioned a case study.
Oh yeah, the workflow case study. The numbers were impressive. Production output up 100%.
Doubled?
Doubled. Lead time to customer cut by 50%. Labor needed reduced by over 26%. Average labor cost savings of 20%. These aren't small tweaks. This stuff fundamentally changes performance.
Powerful.
And there are even simulation games, the source mentions one, that physically demonstrate how much better one-piece flow and leveled production work compared to batching really helps people see it.
Wow. Okay, what an incredible deep dive that was. We went from the absolute basics, those foundational habits like 5S and standard work,
Quick changeovers.
through the whole just-in-time philosophy, takt time setting the beat, continuous flow making it smooth, pull systems and Kanban controlling it.
Right.
And it all comes together in this incredibly strategic approach. Heijunka, production leveling. It really feels like a complete system for operational excellence.
Yeah.
Cutting waste, boosting flexibility.
It really is a system. And connecting it back, this isn't just manufacturing jargon. Heijunka is fundamentally about managing variation, managing different demands on your time or resources, and creating a smooth, responsive flow.
Yeah.
That applies everywhere. Project management, service delivery, administrative work, even just managing your own personal workload to avoid those crazy peaks and troughs.
Absolutely. So maybe the challenge for everyone listening is to think about your own production, whatever form that takes. How could you maybe level your workload, smooth out those peaks and valleys?
Yeah, could you identify a sort of takt time for certain recurring tasks you do? Or implement a simple pull system for how you handle incoming requests or information?
Even starting small.
Exactly. This raises that important question. What if you just applied one or two of these ideas? Maybe started small with 5S in your digital files, or tried to level just one part of your weekly schedule. How much could that reduce the chaos and boost your own efficiency and flexibility?
Food for thought. It's about finding that sustainable rhythm, isn't it?
That's the goal.
Well, thank you for joining us on this deep dive into Heijunka and operational excellence. We really hope you feel better equipped now to maybe start leveling up your own processes.